Hello, this is not your chem tutor, and in this video, I will teach you how to find the empirical formula of a compound from the masses of its component elements. In this video, we will go straight into the examples, and as we answer each example, I will show you the solution step by step. So let's proceed right away to example 1. A compound was found to contain 11 grams of aluminum, 12.7 grams of phosphorus, and 26.3 grams of oxygen. What is its empirical formula? And below, we are given the atomic masses of each element. These atomic masses can be found in the periodic table. So we have the atomic mass of aluminum, phosphorus, and oxygen. So step 1 is to convert the mass of each element into moles. So as we all know, if you want to solve for the moles, that is equal to mass divided by the molar mass. So let's try solving first for the moles of aluminum. So the mass of aluminum, according to the problem, is 11 grams. Divided by the molar mass of aluminum is 26.98 grams per mole. So if you solve this in your calculator, this is equal to 0.41 moles of aluminum. Let's proceed to phosphorus. The mass of phosphorus given in the problem is 12.7 grams. So 12.7 grams divided by the molar mass of phosphorus is 30.97 grams per mole. And this is equal to 0.41. And lastly, we have oxygen. The given mass of oxygen in the problem is 26.3 grams. And the molar mass of oxygen is 16 grams per mole. (26.3) divided by 16, that is approximately 1.64 moles. So that's for step 1. Now step 2, it says here you put the moles of each element as its subscript. So we have aluminum, the moles we have solved is 0.41, so you put that as the subscript. So aluminum, 0.41. For phosphorus, we also got 0.41. And for oxygen, we got 1.64. So that's the second step. Now let's proceed to step 3. So previously, we got Al 0.41, P 0.41, and O 1.64. So in step 3, you pick the smallest subscript, and the smallest subscript is 0.41. You divide all the subscripts by that smallest number. So that means you divide everything by 0.41. According to the rule, after you divide, you round off to the nearest whole number. So for example, after dividing, you got 1.9, you round that off to 2. For example, you got 3.05, you round it off to 3. However, when you get decimals like 0.3, 0.5 or 0.67 do not round off. So for example, you got 2.5. You don't round it off, you just write 2.5. And for example, you got 1.3 or 2.67, you do not round these numbers. So you will see later on, we will have examples where you have zero point 0.3, zero point 0.5, or 0.67. But for now, let's stick to our example. So again, we divide all the subscripts by the smallest number. So 0.41 divided by 0.41, of course, that's equal to 1. So it becomes AL1. 0.41 divided by 0.41 is 1. So it becomes P1. 1.64 divided by 0.41, that is equal to 4. So O4. In chemistry, once the subscript is 1, we omit it in the chemical formula. So the empirical formula is AlPO4. And this is the answer to example 1. Let's proceed to example 2. A compound was found to contain 60 grams of carbon, 8 grams of hydrogen, and 32 grams of oxygen. What is its empirical formula? So we go over again the steps. So step 1 is to solve for the moles of each element. Again, moles is equal to mass divided by molar mass. So let's start with carbon. The mass of carbon given is 60 grams. The molar mass is 12.01. And this is equal to 4.996 moles. For moles of hydrogen, we have 8 grams divided by 1.008. That is equal to 7.937 moles. And for oxygen, the mass given is 32 grams divided by the molar mass is 16 grams per mole. That's equal to 2 moles. For step 2, we put the moles as the subscript. So we have C 4.996, H 7.937, and O 2. So from step 2, we got C 4.996, H 7.937, O 2. In step 3, we pick the smallest subscript. So among the 3 subscripts, the smallest is 2. So we divide all the subscripts by 2. So 4.996 divided by 2, that's approximately 2.5. So again, the rule is when you get a 0.5, you do not round it off. So you just put C 2.5. For H, 7.937 divided by 2, that's 3.9. So you round it off to 4. So H4. And for O, 2 divided by 2, that's obviously equal to 1. So whenever you got decimals like 0.3, 0.5, and 0.67, that's not yet the answer. There is an extra step, which we will discuss, step number 4. So in step 4, whenever you get a 0.3, you multiply all the subscripts by 3. When you get a 0.5, you multiply all the subscripts by 2. When you get 0.67, you multiply all the subscripts by 3. So what we got previously was C 2.5 H4O1. Since we have a 2.5, we will multiply all the subscripts by 2. So when you multiply them by 2, it becomes C5 H8O2. And this is the empirical formula. So for our last example, a compound was found to contain 63.15 grams of carbon, 5.30 grams of hydrogen, and 31.55 grams of oxygen. What is the empirical formula? So again, step 1, convert the masses into moles. So moles is equal to mass divided by molar mass. So let's start with carbon. The mass given is 63.15 grams. Divided by the molar mass is 12.01. So that's equal to 5.26 moles. For hydrogen, we are given 5.30 grams. Divided by the molar mass is 1.008. And that is equal to 5.26 moles. And for oxygen, we are given 31.55 grams. Divided by the molar mass of oxygen is 16 grams. So that is equal to 1.97 moles. So we put the moles as their subscripts. So C 5.26, H 5.26, and O 1.97. So let's just copy what we got from the previous slide. So we got C 5.26, H 5.26, and O 1.97. So we picked the smallest subscript. So the smallest subscript is 1.97. And you divide all the subscripts by 1.97. So 5.26 divided by 1.97, that is equal to 2.67. So again, the rule is when you get a 0.67, you do not round it off. So that's C 2.67. For H, it's the same, also 2.67. And for O, that's 1. So again, I'll just copy. We got C 2.67, H 2.67, and O 1. So when you get 0.67, you multiply all the subscripts by 3. So when we multiply all the subscripts by 3, so 2.67 times 3, that's equal to 8, approximately 8. So C8, H8O3. And this is the empirical formula.